ANOVAs! Hi. This is the first of two videos where we're going to compute an ANOVA using this awesome fake data that I invented. I'm Michelle, by the way, nice to meet you. And by doing by hand calculations, I think this will just help us to understand really what the analysis is doing, instead of just putting it into a statistical program and seeing the results, which is very valuable, but maybe not quite understanding certain aspects of the analysis. So I have this fake data that's been provided by 15 fake participants for us, and it's been divided into 3 groups. To be fancy, I would make up what these groups are, but I'm not feeling very fancy right now. So maybe you will have some funny or interesting group ideas. I am going with the classic group 1, group 2, and group 3. So you see here are the scores provided, the dependent variables provided from each of the 15 participants, 5 in group 1, 5 in group 2, and 5 in group 3. The first thing that I wanted to do is to find the group means. Sometimes when you read a textbook or a source that talks about doing these ANOVAs, they use the X bar for the mean and then the subscript J, which is generally reserved for the group number. So J would be 1 for this mean here, J would be 2, and J would be 3. Doesn't matter. You can ignore it for now. Really, what this is saying is, please let's find the means of each of these 3 groups. So if you want to practice doing that, pause the video now. Okay, hi. And I'm going to put the means in. So the mean of this one, I wonder even if you could do mental arithmetic. Oh, maybe not. Okay, because this one is 1.8. And this mean for group 2 is 3.2. So yeah, maybe not so much mental arithmetic. This one, maybe you could. It's 7. So interesting. So the lowest mean is for group 1, followed by that for group 2 and group 3. And we're going to be asking the question, do at least 2 of the means differ, by doing a one-way ANOVA for between subjects design. Cool. The next thing I wanted to compute is this within group sum of squares. So I denoted it by saying, like, each of the individual points, you subtract the group mean, so you go like 1 minus 1.8, and then you square that, and then you add, you go 2 minus 1.8, and then you square that, and then you add, and so on. So if you want to practice doing 1 or more of those on your own, go ahead, then you can pause the video. Okay, cool, because pausing does take time, so now I'm just going to keep going. So then what we would have for this, after doing the 5 different squares and then summing them, if I did not make any mistakes, is I get 2.8. And then for group 2, I also get 2.8. Ooh, fancy. Just fake data, so maybe I engineered that, maybe I didn't. Who cares? This one here, I get something a lot larger. Each of these numbers is larger and a bit more far away from the mean than these guys is. So I actually got 90. Yeah. And if you don't feel like computing these and you just kind of want to see the ANOVA, yeah, you can always go forward. I usually do very slow, detailed instructions. So yeah, feel free to like just go forward. And yeah, so then here, this is the symbol that I'm using for the variance for group 1 and for group 2 and group 3. So if you forget how to do a variance, or just kind of want to remind yourself like what the formula would look like, what you would need, by all means, pause the video, check that out now. So I hand computed them beforehand. So for this group's variance, I got 0.84. And then that's a 0. And then for this group's variance, I also got 0.84. And then finally, for this group's variance, I got 4.74. So that's interesting. This is, you know, like I made them so that they'd have weird looking variances between them. Like this one has a lot higher variance than these two. And so that's fine. Again, like I won't get into that. That could be like a different video to talk about a different thing. But now we want to compute the one-way ANOVA before everyone gets super impatient. So first thing we're going to do is we're going to compute the grand mean. You might see it denoted by x bar, the mean with GM for grand mean at the bottom, or maybe the more traditional one, which is, by traditional I mean I also like it, which is just an x with two dots at the bottom. So the way that you would do that is you would just sum all these numbers together and divide by 15, but if you want to cheat, because this group size and this group size and this group size are equal, they each have 5 observations, you could do a cheat. Only in this circumstance though, where the group sizes are equal. You can add these 3 means and then take the mean of those means and divide that. Take the mean of those means by dividing by 3 rather. Okay, so however you wish to do that, I'm gonna do it the cheater way because that's just me. So it would be the mean of group 1 plus the mean of group 2 plus the mean of group 3. I'd be dividing that by 3, and so that is equal to, I know you know how to find a mean. Just, you know, it's nice to show every step. All right, so then 1.8 plus 3.2 plus 7, and we're going to divide that by 3. And again, if I hadn't made any mistakes, I get 4. Don't know what you get, but we'll just go with 4 for now for the concept. So the next step I want to do after finding the grand mean is I want to use that grand mean to find the sum of squares for the group, or SS group, or as you might know it, SS effect. So in order to do that, maybe I'll work on up here. So like step 2, I want to look at the SS group. And to do that, we need to locate the formula for that if you don't have it in your head, which would be understandable. And so we're going to have a little n, and then the sum of, and then this xj with bars, so like the group mean here, and then minus the grand mean, and we square all those and we sum them. But then we also have to multiply by this number here. That might get confusing later, but this number here. So, and that is the size per group. So let's get that ready. And if you want to try that on your own, I actually highly recommend it, because this is, if you're learning this one way between subjects, analysis of variance or ANOVA, it'll be nice to do it by hand on your own and screw up and get frustrated and then learn by going back and correcting yourself with the video. So do that, but if you just want to see, let's see, so our n is 5, and then I'll open up a big square bracket so I can do this stuff here. So the first mean for the group is group 1's mean, which is 1.8, and then we have to subtract the grand mean, but then we have to square what that number is. We do that, and then same thing for the other ones. So that is 3.2 minus 4, and you square that, and then I need to, have to fit it in. It's very important. I need to have control over a situation in my life, and it's this one line that has to stay one line. So 7 minus 4, okay, that's easy. We could have just written 3. Okay, and then squared, and then close my bracket. Okay, so when you do all that, so we have 5, and then I'll just put what I got for the individual squares. So I got 4.84 plus 0.64 for this one, and then for the 3 squared, okay, spoiler alert, I got 9, and that equals 72.4 when we add all that up together. So that is the sum of squares group that'll help us to compute the ANOVA. The next thing I'm going to do is I'm going to compute the sum of squares error, and it's going to help me to have these these were like the within group sum of squares, like individually. So that'll help me to get the sum of squares error. So there's other ways that you could compute an ANOVA. You definitely need this number and you need to compute it right away from scratch. There might be other ways, like if you wanted, you could compute the sum of squares total. And I don't feel like it, because you'll see why. I think I'm going to go with the SS error. So then 3, right, SS error. So this is going to represent the, all the scores are kind of different, right? They vary, there's variance there, and some of that variance is not going to be due to the fact that we separated our participants into 3 groups. It's going to be due to the fact that there's like weird noisy things that happen, like for example, maybe I don't know, like this person happens to be very, very good in this particular group's task or whatever, and so kind of like pushes this group's mean higher, and so that kind of thing can be captured in the sum of squares error computation. So to do that, what you would want to do is you'd want to take this minus 1.8 squared plus this minus 1.8 squared, blah, blah, blah. So you'd have that. And then you'd add to that the same process where you look within each group, or the within group variance, and you would compute the individual minus that group means squared computations, and then finally you would do it here. But because we've already done it, here, here, and here, all we have to do now is to add them up. So then I'll add them up. So we would have, what is that, 2.8? Yeah. So it'd be the sum of all these individual scores minus the group mean, where, depending on which group they're from, you square that, but then we kind of already did those, so you would just have 2.8 plus another 2.8, and then within group variance for group 3 is 90, and yeah, so that equals 95.6. Okay, so now it might be helpful for me to square the 72 not square, put it in a square, and box off this 95.6. So we're getting close to being able to compute this ANOVA score, or F ratio, or whatever you want to call it, F statistic. What do we need next? So you need to divide the sum of squared group by a number. You need to divide the sum of squares error by a number. And the number for sum of squares group that this needs to be divided by is the degrees of freedom for the group. So right here, I'm going to say we have the sum of squares. We need the degrees of freedom for the group, or of the effect. So the way we do that is we look at how many groups there are and then subtract 1. 1, 2, 3 minus 1 is 2. I feel so brilliant right now. Did not need a calculator. Couldn't say calculator, but you know. So that's 2. And then for the SS error, how would we do that? That's tricky. Maybe for the SS error, the degrees of freedom should be calculated like this. So the degrees of freedom error, it's going to divide this number, can be the degrees of freedom total minus the degrees of freedom what? Of the group. So there's a kind of a fancy way to do that. So the degrees of freedom total we need to figure what that is, but it's simple enough that we don't have to do it a separate calculation. Minus the 2, that is the degrees of freedom group from here. This is getting very messy, but I'll erase it at some point. Yeah, so degrees of freedom total is always big N minus 1, where big N is the number of observations total. So we have these individual scores, there's 15 of them. So in our case, it would be 15 minus 1, big N minus 1, and then we'll have subtracting the 2 for the DF group. So again, I can do this in my head. So 14 minus 2, so 12. Perfect. I'm going to check to make sure because I'm nervous. Is it 12? What if it's not? It is. Okay, perfect. So now I had a purple one of these, but then I was messing around in my bathroom on my bathroom mirror, and then I dropped in the toilet, and then I just didn't want to write with it anymore. Anyway, that's my secret. So then this 72.4 will be divided by 2, this 95.6 will be divided by 12, which will make what? What will this division and this division create? It'll make for us the mean squared of the group, or the mean squared of the effect, MS group. And here, the mean squared error, we like to call it MSE. And yeah, this is a good time to compute those. And then, this is exciting, we're almost done. Yeah. So, okay. Yeah. Okay, so try and get ahead of me, like if you're feeling like you could, then like take these numbers, make your mean squareds, and then if you want, even compute your F ratio or F statistic or F whatever number, and then you can see if you got what I got. So, oops. Okay, so I'm gonna cover what I'm doing here, but I'll rewrite it. So MS group is equal to SS group divided by the degrees of freedom group, which, I mean, you wouldn't have to write this out over and over again. You know that it's 72.4 divided by 2, right? But I'm just trying to be clear. So that would be 72.4 divided by 2, and that's equal to 36.2. And then you can also do the same to find our mean squared error. Sometimes we call it MSE, or sometimes just if you prefer or someone else prefers, they might write it like this, or in even a more convoluted way, which I will not attempt. So then, let's see, we have to take this number, 95.6, that we computed, and then we're going to divide that by the degrees of freedom error, which is 12, and when we do that, we get 7.97. Oh, this is exciting. Okay, so we have a mean squared group, we have a mean squared error. We know our degrees of freedom, 2 for the group, 12 for the error. We don't need any more of this. So, and like I have a thing where I refuse to edit my videos. I like to think it's because I want people to get the raw and complete lesson, you know, with everything, including my weird comments about the marker that fell in the toilet. But really, I'm just lazy, okay? So, and anyways, you don't get to edit stuff when you're in front of a class, right? So, kind of an authentic experience. So, we're going to find our F ratio, and that's going to be our MS of the effect, or the group, always on the top, divided by the mean squared, or MS, of the error on the bottom, or sometimes MS capital E, as I said before, and that's equal to 36.2 divided by 7.97. And when you compute that, perhaps with a calculator, and you round, and you might have some different rounding, because I was very lax with my rounding. I just was sometimes rounded to 2 decimal places. We didn't even use these numbers though. So yeah, you might get something more accurate. But what I get when I do what I did here is I get 4.54. And that is my F statistic. Okay, so then I would report this. Okay, so the result, I would say F And then I would put the degrees of freedom for the group, which is 2, then comma, degrees of freedom for the error, which is 12, and I would set that equal to 4.54, and I would keep 2 decimal places and only 2 decimal places for the F statistic, because that's how we report it in manuscripts. And then that's it, that's the end. No, just kidding. You want to know if it's significant, right? So then what you would do is you would appeal to your table, or if you're using statistical software, it has a fancy table that it can kind of generate and use itself. But we could look up in the F distribution table for an alpha of 0.05. I stumbled there and I said a p, but yeah, you look at your alpha equals 0.05 columns, and you'd be able to see that F crit, or the critical F, or whatever you call it, is equal to 3.89. So because this one is greater, the observed F, than the critical F, this fancy group 1 versus group 2 versus group 3 between subjects manipulation resulted in a significant effect of group. And that's that. The next and last video in this mini series of 2 videos is the same data and the same process, but we're doing a within subjects design. So we're just gonna change the way that we look at these data, and we'll do that. So I'm going to now do the old school turny offy thingy. Okay, thank you and goodbye.